I'm going to be discussing postulates and axioms. These are statements that you kind of accept as true. It is what it is. You know, it doesn't really need any proof. Kind of like the color red. There's no really definite proof that the color, this pen right here is red. We just accept it for what it is. You can't prove it that it's red, besides the fact that everyone from the beginning of time, of your time at least, has always said that this is red. So that's what kind of an axiom or postulate is. And these are some very important postulates that have to do with points, lines, and planes. Okay, this is what I was talking about the other day. Through any 2 points, there's exactly one line. So a line is defined by 2 points. Okay, now I want to show you why. So let's say I have 1 point, right? Well, if I have 1 point, how many lines go through that 1 point? Well, because there's no second line, since there's no second point, there's millions, an infinite amount of lines that can go through that 1 point. That's why in order to have a line, you have to have 2 points. Okay, you can have more than 2 points, but you have to have at least 2 points, right? Okay, and then postulate 2.2 says through any 3 non-collinear points, there's exactly one plane. So remember, non-collinear means not together on the same line, right? That's what that means. Okay, so as long as these 3 points are not together on the same line, then there is one plane. Well, the reason being is because if I have 3 collinear points, that forms just one specific line, right? But I need a plane. There's thousands of planes that can go through that same exact line, which is why you need 3 points. So I would need another point here that's not on this line so that I can determine that plane. Make sure when you write planes that planes are described by the letter K. If it's not a point, it's describing the plane. It's in lowercase. Also, when you're describing the plane as the 3 points, you need to call it plane. You need to use the word plane, A, B, C, capital letters, please. Okay, a line contains at least 2 points. This is kind of the inverse of what we said here on 2.1. Okay, through any 2 points, there's exactly one line. A line contains at least 2 points. So it can contain 3, 4, so forth, and so on. It can contain as many points as possible, but it needs at least 2 points. Okay, and then again, vice versa, a plane contains at least 3 non-collinear points. So it can contain 4, 5, or 6, but it needs at least 3, right? And when it says at least, that means greater than or equal to 3, which means it can't be 2. It has to be 3, 4, 5, 6, 7, and so on. Okay? Make sure that we understand that a plane contains at least 3 non-collinear points, not together on the same line. Okay? If 2 points lie in a plane, right? 2 points lie in a plane, then the entire line containing those points lies in a plane. And that kind of makes sense right here, because on 2.1 it says through any 2 points there's exactly one line. So if I have 2 points on a plane, then there's one specific line that goes through those 2 points that's also on the plane. Okay, points A and B lie on this line M, and they're in plane K, right? Now A and B don't define plane K because there are 2 collinear points. I would need a third point that's not on that line, just the FYI. Okay, so some more postulates that we want to talk about for examples, right? If 2 lines intersect, then their intersection is exactly 1 point. So when lines intersect, they intersect at exactly 1 point. Okay, lines S and T intersect at point P. Okay, if 2 planes intersect, then their intersection is a line. Okay, so planes F and G intersect at line W. Now remember, there's several points on this line, so that's why, remember, we can have at least 2 points on a line. Well, that's why a point doesn't determine an intersection of planes. Okay, so make sure that you understand that. All right, kind of when you see a paper, right? A piece of paper, and then you poke a hole through it, right? So here is your piece of paper, right? The paper is the plane, and the pin is a line, right? It goes through this plane, right? And there can be several different planes. I could stack another piece of paper here, have two parallel planes, which we'll talk about in the Nearpod, okay? All right, so there goes those notes now that I've trashed them. I'm going to talk about a couple of little things real quick to determine so that you understand if each statement is always, sometimes, or never, right? So if two coplanar, that's on the same plane, lines intersect, then the point of intersection lies on the same plane as the two lines. So we have this picture right here, two coplanar lines, right? So that means they're on the same plane. So here I'm going to have a plane. So two coplanar lines, they're on the same plane, intersect. Right? Then the point of intersection lies on the same plane as the two lines. Well, that should make sense. That should be an always, because these two lines are coplanar, they're together on a plane, then that point also lies on the plane. Okay? Next one says 4 points are non-collinear. Okay? Is this always, sometimes, and never? 4 points are non-collinear. This is a sometimes, right? 4 points, because I can have a line that has 4 points, and all 4 of these points are collinear. But then I can also have a plane that consists of 4 points. These 4 points are not collinear. So this is a sometimes. Okay? So I'm going to go ahead and stop it there. Sorry about that beep.